It's the language that has the intelligence of a 2-year-old because all it does is say yes or no to every question.
Hello, welcome to Security, Cryptography, whatever. I am Deirdre.
I'm David.
I'm Thomas.
And today we have another special guest.
Hey, I'm Jonathan Rudenberg.
Yay, welcome.
Jonathan Rudenberg, you should tell us a bit about yourself.
I have been working on various software engineering projects for many years now. The most recent project I worked on was Flynn, which was an open source platform as a service. And I built a bunch of that. And I also built all of the authentication systems for the system across a bunch of services that were potentially running in different places and had a lot of different clients.
That is extremely useful because today we are asking why JWT tokens? Why do people still use them? Why are they a pile of shit?
And we begged Jonathan to join us for this episode. I think
Yes.
there's probably an expectation that we're going to trash JWT, and I sure will. But I think also some of us have surprising opinions about JWT.
Yes. Yeah, I mean, we have reasons to trash JWT, and yet everyone who is trying to build some sort of web service with authentication seems to keep reaching for JWT. So who can tell us what JWT stands for? Like the acronym.
None of us know it.
JSON Web Tokens. That's what it stands for.
Establishing our credibility right off the bat here.
Okay, number one. The JWT stands for JSON Web Tokens. And spoiler, the name in the detail tells you a little bit about what's going on, which is just, it's kind of a blob of JSON that tells you what your signature algorithm is, what your key type is, and some other metadata. But you can malleate it. And one of those signature types, one of the signature algorithms that you can define in your JSON Web Token is none, which is bad, but that's not it. So
I feel like, first of all, as always, I'm probably wrong, and I'm also tipping my hand a little bit. But my general take on what JWT is, web frameworks have had for more than a decade now, they all pretty much have some kind of signed cookie. They all have a notion of a session. And a session is a bag of attributes. It's your user ID. It's like the last action you took. It's whatever random crap people want to remember about requests. And
yes.
Frameworks have all, for a long time, wanted to do something close to stateless authentication for that stuff, which is just to say that you want to be able to stuff all that stuff in a cookie, sign the cookie, and then not have to remember it in the database. There are really simple reasons why people want to do that, like adding new bits of information requires database migrations, which are a pain in the ass to do. So like it's easier just to stuff something in your session and then remember it in a signed cookie. So Rails, for instance, has message encryptor and message signer or whatever they call it. And that's, to me, JWT is essentially a sort of interoperable version of message encryptor or whatever Django does, or Fernet from the Python cryptography people. It's just like a cross-platform version of that with extensible cryptography and that uses JSON as its format.
You see extensible cryptography and my awoogas start going off.
We're all being very calm about a bad situation here, but did I get any of that wrong? Do any of you disagree with my kind of summary of what JWT is there?
I think that I would disagree a little bit in that you can just stuff random stuff in a JWT token, but for the most part, it is usually used to convey some kind of identity, usually a username or a user ID, and then maybe some additional metadata. And there are some specifications like OpenID Connect, OIDC, that also have definitions for specific fields that would go in the JWT. But in general, my experience of it is that it is not as used as commonly to convey just like arbitrary data in the same way that the Rails message encryptor stuff would be.
But it's also not quite JSON. It's 3 different JSON blobs that are then base 64 encoded and then separated with periods. So when you're actually parsing them, you have to split out the periods, then decode the base 64 or URL encoded
Yeah.
version of base 64, and then you get 3 different JSON blobs.
It's true that JWTs are usually just
sorry,
used.
I misspoke too, because the last blob is the signature.
Right. And you have to decode, so the header is the first blob, and it has the algorithm that is being used, and you have to decode that in order to use the token unless you've specified a static profile for the token. And you have to do that before you check the signature.
I guess I'd just start with what do we think the sane forget JWT, the standard, or its implementations, or all of that chaos for just a second, and just sort of stipulate that JWT was okay. What are the sane kind of scenarios in which you'd want to use this thing? Like, why do we have it?
Oh, right. Like you said, you want a session storage. You probably want it to be stateless or almost stateless. We can talk about revocation and when you should be checking state on these things later. But you want the session token, you want it to know that you issued it. You want authenticity or availability, whatever we're using to describe that property nowadays. You want integrity. You want to make sure that the thing you issued is the thing you got back, that nobody added other stuff to it. In some cases, maybe you want confidentiality. I don't quite understand why you would want that, why you would want to hide the data that you're putting in the session from the person you're giving the token to. And then in other more complicated cases, you might want these tokens to be verifiable by a third party, or even if not a third party, to be verified by a separate service.
Yep.
Say you have, example.com and you have login.example.com. You probably don't want to share an actual secret between those two apps. You want example.com to use public information to verify something from your login server in an ideal world. Or maybe you don't even run your own login server, right? You're using a third party as your identity provider. In that case, you're definitely not sharing secrets. So you might want these to be verifiable using only public data and not a shared secret.
Yeah.
I guess until you get to that public data, you're still talking about things that Rails message encryptor or Django sessions already give you, right? Like, I guess I'm still a little mystified as to how JWT took off the way that it did. You might be able to blame OIDC for it, because OIDC, for reasons passing understanding, baked JWT into the standard. OIDC itself is a pretty simple idea. Like, you're about to disagree with me, which is great. But my take on it is that OIDC had a very small problem to solve over OAuth, and bit off 10 other problems that it didn't need to solve.
My feeling was that there was an RFC for it, and there was no real RFC for any other general interop web token. And so it just sort of won and just kind of built momentum, built multiple implementations and languages and frameworks, and then there was no strong competitor. That's my feeling. Jonathan?
I completely agree. I think it's just an IETF snowball in that there is a specification, therefore we must use it.
And even beyond that, I was in a situation recently where we had a Python web application and a Node.js web application. And for reasons, both of these needed to parse the session tokens. And okay, great. What are you going to use then? You're going to put a protobuf encoder in your Node.js app? Yeah, that's possible. But really? You're going to roll some custom crypto and JavaScript? No, thank you. The JWT libraries exist. And if you hard code in effectively a static profile around them in your own application layer code, where you always know this is going to be the public key, this is going to be the name in it, this is going to be the algorithm, and you reject everything else, they're definitely possible to use safely.
Yes. If you hard code your the parameters of what you're trying to use, if you hard code your algorithm and the types of keys that you're using somewhere, and everyone uses that, then you lose a lot of the sharp edges of JWT. But if you don't, it's got a lot of sharp edges. And kind of what David said before, the last time I had to roll out JWT, it was basically trying to do this sort of work with a third-party service that we did not control. And it kind of infects basically anytime you're trying to interop. What are you going to decide on? Oh, will we support JWT? They're okay, I guess we have to build in support for JWT here. And then if we build it in here, then if there's another thing that we have to interop with down the road, then it kind of infects that one, and so on and so on and so on.
Yeah, and I think that's the scariest part of it is because you end up using it in places where maybe it wasn't as planned. You end up with other services that you don't control using it, and they don't necessarily have the same level of static profile that you may have applied in the first implementation of it. And so if you're not extremely careful, you end up in a situation where you are vulnerable to these pretty well-known attacks. You've got type confusion, you've got this none algorithm, and there have been other issues around just the actual implementation details of each of the libraries.
Could you explain what those actual vulnerabilities are in more detail?
Yeah, so the type confusion attack is where you end up using a token that you're expecting to have, say, an HMAC token, which is symmetric with a secret.
Mhm.
And the verify function, you pass the token and the secret in. And the verifier will just kind of blindly check that. But if an attacker swaps the algorithm in the header of the token, for example, actually, sorry, it's the other way around. If you have a token that you're expecting to verify using RSA, you would pass the token and the public key into the verifier.
Mhm.
And then an attacker can change the header to be the HMAC algorithm, and you end up passing in the public key as the key, and the public key is no. So you can end up with a token that verifies using the wrong algorithm effectively.
Fun. And
And
by
there's-
fun,
there's
I
a-
mean terrible.
There's an even simpler version of that where, again, for reasons completely passing understanding, their JSON web tokens, their whole reason for existing is providing some kind of cryptographic authenticity for tokens. But one of the algorithms is none. There are systems that accept tokens where the header has been swapped so that, like, oh, the algorithm we're using to authenticate this is none. And there are systems that trust it. So that's one of them. There are other problems with the standard, right? There are weird problems with it too. Like, I have a lot of problems with JWT, but one of my problems is I'm just not bought into the idea of extensible JavaScript or JSON tokens, arbitrary bags of JSON as security artifacts, right? So for instance, you have a namespace inside of these JSON blobs for metadata for the token. But if you look at a lot of app code, when they have a construction like that, when you have the ability to just like, here's a bag of attributes and you can put stuff in the bag of attributes, it's not at all rare to find code where it's like, here's user input, marshal all the keys and values from that user input into the bag of attributes. And that's problematic when that bag of attributes has, things that have semantic meaning in them. There are other problems. Expiry and revocation are optional and weirdly specified. And I'm probably not capturing all the things that are going wrong with JWT, but
You have a unique perspective on this because you did, pen testing and vulnerability research and consulting for a while. But at least in my experience, I don't see a lot of people putting arbitrary data because it's JSON into the token versus like the one or two fields that are either required by the provider that they're using or like the bare minimum to say like user and group type identifiers.
I guess I see it used two different ways, right? And there's a way in which it's used where I don't have as much of a moral objection to it, which is it's the interoperability layer for doing, sign in with Apple or sign in with Google or something like that, right? Where you're just implementing exactly what the flavor of OIDC and JWT that they're asking you to do to get that feature working. And then there are the people that have drunk the Kool-Aid and are using JWT because they want stateless authentication and more broadly stateless sessions. And like a drum I beat a lot is how underrated simple random tokens are for this stuff. Like
Yes.
I'm not totally bought into the idea of look for third-party dependencies when you're trying to get sign in with Google working, right? Like, fine, obviously that's got to be stateless somehow because you don't share a database with Google, right? But in real ensemble systems, even fairly complex ensemble systems, statelessness tends to break down anyways, right? I think it's overrated in that at some point you're always introducing some kind of database-backed state somewhere anyways. And you're not winning anything from adding the complexity of stateless tokens when you do that, but you still have people kind of using them as a general session store. So that is a thing you see, and you see it in places where people are using JWT because it's a cool cryptographic tool that they're like
Is
cookies
it
plus.
though?
They're cookies plus, right? Like they're the better cookies. There's a whole species of security commentary about don't use JWTs in local storage as session tokens for all the reasons that local storage is less secure than cookies. So I do see stuff like that.
Specifically local storage in the browser, right?
Yeah. I guess like the point that I would make is when you're doing interoperability with other systems, the most mainstream way of doing federated authentication is SAML, which is the worst cryptographic protocol on the internet. There isn't a worse one, right? So at the point where I accept that you're doing SAML, I obviously, I don't have a leg to stand on to say that you shouldn't do JWT. SAML is in every possible way worse.
Is SAML, I don't know if SAML is more common or not, but I feel like there may be a crowd of people that want to use JWTs because they think they're the uber awesome token. Maybe these are the same people that just want to roll their own crypto anyway, and they're the people that we talked about who aren't going to listen to us at all in the previous episode with Filippo. But
I'd argue that it is not rolling your own crypto to use the JWT, though. It is the only off-the-shelf solution that will just work.
Yeah.
And the alternative is actually usually rolling your own crypto when like signing a Protobuf. But I guess where I was going with it is I feel like most people are using them because they're speaking OIDC. Like I think OIDC, it's not just that JWT is a standard. It's that OIDC, unlike regular OAuth, specifically says you have to use a JWT and here's how it's going to work. And that is how you do sign in with third-party services. And that is how when you go to Auth0 and you buy their user products, they're using JWTs. They're the people running the website, JWT.io, that is encouraging people to use it. At the same time, they have an algorithm none vulnerability like once a year.
Oh.
I think they've had, 3 of those now, and they were bought for $3 billion. So I guess that's $1 billion per
Billion
algorithm
with a
none.
B?
Yes.
Oh my God.
They were bought by Okta. So if we had a competent SEC, the acquisition probably wouldn't have gone through. Like that type of integration, I think, is what's driving the adoption here. It's OIDC, third-party services. And again, like you don't really have another option there.
I think that there is one interesting point about using for OIDC, which is if you're just implementing the simple sign in with Google flow, you don't actually need to do any of the JWT things. You got the token over TLS from google.com. And so you can just decode the middle segment, which is the JSON blob that contains the username, and you can just use that. And you don't have to do any checking of the token. In fact, when you add in, am I going to use the certificate from the discovery document and all this like more complex stuff, you introduce more risk into your system.
Do we want to talk about how OIDC works? Do we want to talk about other tokens first?
I want to know more about OIDC because I rolled out JWT in some systems and it did not have any OIDC in it. So I would like to learn more.
Can I take a stab at defining OIDC that will be wrong, and then we will all learn through you guys correcting me. So in the beginning there was OAuth, right? And OAuth is a way for me to post tweets on your tweet stream. Right. Seriously, that's like the idea. It's like it's delegated access to some sub resource of an application, right? And
it's doing things on behalf of someone else.
And people quickly realize that if you can do that you can use the delegation of some resource to prove that you're a user, right? So like access to your Facebook account details or your username or somewhat that on Facebook, that's been delegated through OAuth. You can use that to prove that this person has a token that gives us access to his Facebook profile. So ergo, that person must be that person, right? And it turns out that breaks down pretty quickly, right? Because delegated access to a resource is not the same as your identity. People don't use it the same way. So there were all sorts of vulnerabilities where people were taking benign looking OAuth tokens and using them as identity tokens for dumb services that had tried to implement like login with Facebook that way.
Oh no.
And you mean that like a Facebook user did an OAuth to let somebody like post on my wall because it's 2009 and walls still exist. And then someone takes that OAuth token and then uses that to sign in as me, the Facebook user on a different site. Like what?
Yeah, I think
what was going wrong there?
I think like I'm off on the details, I'm sure, because I don't have it in front of me. But I think it's basically that, right? It's like access to post on my wall becomes a bearer token saying I'm this user, and then there are systems that trusted that. And so the idea behind OIDC is that it's like a profile of OAuth. It's the same OAuth protocol, but it's like a profile of OAuth that embeds tokens, and those tokens have like rigidly defined meaning that like these are bearer tokens for authentication. These are intended to prove that you're a specific identity. You can imagine implementing that without any of JWT, I think, right? Like you would just need some kind of well-defined definitions of what fields are and what like scopes mean or something like that, right? You probably don't need an extensible bag of cryptographically authenticated attributes. But that's
Do
my
you
understanding of what
need,
OIDC is.
I mean, you need, after the code exchange, you need a defined thing that has a defined field in it that says this is my identity and then is verifiable by third parties, right? Like that's what you need at the end.
Right, but
You could,
an OAuth token sort of already has that in the sense that they're already scoped.
I would say that it doesn't need to be verifiable by third parties per se. If you are the relying party and you get a token over TLS from the identity provider, you know you got it from the identity provider. So it doesn't need to per se be third-party verifiable. OIDC has this property where the JWTs are third-party verifiable in most cases. And so you can actually get up to shenanigans with them. And I'm just not convinced that any of those shenanigans are actually a good thing.
What if you are a very large provider like a Facebook where you have a bazillion certs, you may have multiple certificate authorities issuing those certs. How do you ensure that if you are just trusting the fact that you connected to someone who you can verify their certificate chain all the way down to a certificate authority root cert, that that's the one?
I mean, secure your auth service properly.
But isn't this how everything goes wrong on the internet at all, ever? Like, isn't this the original sin here is, what if you were Facebook and you had this complex topology that you needed to support, right? And there's a standards discussion where we're discussing, okay, we need to add some kind of metadata to an OAuth token to say it's an identity token. But what about all these other scenarios that Facebook and Google have? You know, make sure that the standard captures every possible wrinkle of how they'll do it. Never mind the fact that they're Facebook and Google and they will ignore the standards anyways. They have better implementations of all of this stuff. They're much more familiar with their own topology than the IETF is, or whatever godforsaken standards group came up with, you know, whatever, right? In the end, what happens is that you end up with, you know, smaller organizations that should be exploiting the fact that they're not Facebook, right? That they don't have any of these problems.
Word.
But they're dealing with standards that are kind of, I don't even know that Facebook and Google look at these things and say, well, this does a great job of capturing what we're trying to do. This is absolutely best practices. I mean, maybe these are the organizations that brought us Kubernetes, right? So it's possible that they do think that way, right? But I guess not, right? I guess that like, it's just like it's kind of like a grotesque, monstrous version of what they're trying to do that's been filtered through standards bodies. And then the people that are on the receiving ends of these things that are actually putting them into practice don't have any of the context for why these things are that way or what the pitfalls are to doing that. So like, Jonathan, you're describing scenarios that are kind of sane, where it's just like, I'm trusting TLS. I'm in direct communication with the IDP that's, you know, that I'm relying on to sign somebody on. And that's the end of it, right? I need to get the user ID from this TLS connection to this trusted IDP, right?
Yeah.
But the token asks you then, well, do you want to build a bunch of backend systems where you can pass that token on and they don't need access to the IDP to verify this? Sure. I mean, you could just build your own inter services authentication thing and you would have a much better idea of how that works. But instead, you could make the JWT standard do all of that for you.
Jonathan, could you explain when you do or do not have to like trust TLS within OIDC?
So if you are the direct RP, the relying party for the transaction, and you
the relying party is like the app. So it's like I'm app.com
exactly.
and I'm trying to use google.com as my identity provider to sign in a subject who is the user, correct?
Precisely. And in that case, you can just fetch the token over TLS as the last step of the OAuth to OIDC process. And you can just throw out the header and the signature and just decode the base 64 in the middle, and you have JSON that you know you got from the right place.
Nice.
It becomes much more complicated if you decide to reuse that token for other services. In that case, you need to check the signature, which means you need to fetch the keys that were used to sign the token and have a system for refreshing those and discovery. And you end up with potential vulnerabilities around not only the headers and the design of the tokens, but also around what's in the token itself and how you're using it, right? So if a token is not scoped correctly to your service, someone could get a token from another auth transaction potentially on another service that was meant for something else and then just pass it in and use it to authenticate within your service, unless you're very careful with how you're using them.
So what about not JWT?
I think like before not JWT,
Okay.
like I've spent the last several years reading cryptography engineers kind of slagging JWT. So like there's a practical case for using JWT. The obvious practical case is it's the way that you implement sign in with Google and sign in with Apple and all that. Fine. But for systems where you don't need it, for systems where you have some design flexibility, what are the things that Jason got right? Because we can rattle off things that Jason got wrong, right? Like Sophie Schmig was on Twitter the other day kind of with a thread, and it's a thread I've read from a lot of other people too, and I feel like it bubbles around, but it never kind of breaks through into the mainstream, just core design flaws of this protocol or this token format, right? The number one has to be that it's a token, it's a fairly complex token, compared to other tokens, where you have to parse it to understand how to verify the
Yes.
authenticity.
Yes.
What else? Because there are other things that are wrong with this.
And because I wanted to bring up Sophie before, because I love her. If you're ever going to design a thing, anything like this again, take the properties of the keys with which you are verifying stuff and bind them together. She gave a very good talk about this at Real World Crypto at some point in the past 2 years, where that literally it's that. If you have a key, whether what kind of key and what algorithmic parameters, and like if it's an elliptic curve, public key or whatever, what curve it is, are all bound to the key so that you can never accidentally use an HBAC and try to turn it into an RSA, kind of like the example that Jonathan was giving earlier. That is not what happens in JWT. But yeah, what else?
Well, there's the fact that like encoding this can and cannot be a problem, but like encoding JSON isn't well defined. What order do the fields come in? All numbers are floats, but sometimes they're also strings. What's your JSON decoder going to accept versus what's it going to spit out versus what was actually there and you expected? It's just a very weak format, and weak formats tend to be harder to use in anything that's being cryptographically verified, unless you're very careful on how you do it. You have to keep the decoded version around, verify that, then decode it afterwards, which you're encouraged not to do here because you have to parse the header.
Mm-hmm.
Jonathan, you're on the CFRG mailing list. Your job has required you to answer questions on CFRG because you're cursed. And somebody brings JWT to you for the first time, and you're going to do your best to stop it from being a terrible, terrible cryptographic standard. What else are you going to tell them not to do?
I mean, I think that having the algorithmic flexibility in there is a bad idea. Like, you have to just pick the exact specs you want for a token and have that out of band with the keys, not in the token itself.
Right.
I have a spicier take on that, which is, and this is a place I think all three of you might disagree with me, but I see this kind of a design smell when I see any kind of format where there's selectable public versus symmetric key encryption, where there's a mode where it's deployed asymmetrically and a mode where it's deployed symmetrically. Like it's the same format, but you can use it both ways. To me, those are radically different deployment environments. They're basically different protocols at that point. They have different security properties. You manage them differently. They're just not the same thing. And in addition to kind of the flexibility you have to pick algorithms and, how that's not tied to keys and all that, there's also just the fact that JWT tries to be these multiple different things. There's, again, it's back to like, there are sane ways to deploy JWT because you have to for Google, but that has one profile that it's deployed in. It's a common profile. It's the way that people ordinarily do it, right? But it supports all these other deployment modes that just beg people to use them. And, it's not specialized to any one of those things. It doesn't do a good job of any of those things. Am I wrong about that? I think you could make a case that I'm wrong.
I think you're absolutely right about the whole symmetric versus signatures thing. And to compound the problem with JWT, in nearly all of the docs that you read about it, it still refers to HMAC SHA-256 as a signature algorithm.
No.
Which is deeply frustrating because it's not. And then I don't know if you've had this experience, but a conversation of like web developer going, hey, we're introducing JWTs and we're going to use, here's why we need to do it because of reasons I discussed earlier. and then, we're going to use like HMAC as our signature algorithm. And then I go, that's not a signature algorithm. And they're like, well, it's in the docs. And then like, now you're just arguing over something that like, you didn't really want to have that argument. That's not the thing you wanted to explain to somebody else, or to like, that really limits the correctness of the deployment. It's just, we're talking with different terms. Now we're already off base, and we haven't even gotten to what does the deployment look like.
Yeah. And just to,
so I think I'm even stronger against that on you, just because I'm so annoyed that they call it that.
Yeah. And just to quickly give context, we're talking about a signature as an asymmetric public-private key signature, such as a DSA, ECDSA, and RSA, whereas a MAC or an HMAC is a message authentication code that relies on a symmetric shared secret to verify. So that's what we're talking about.
Kind of additional fun times for JWT here are, in addition to the fact that it has a mode of deployment for symmetric and a mode of deployment for asymmetric, within asymmetric, you have multiple options for how you're doing the signatures. One of them is P-curve, elliptic curve. There were, I think 3 or 4 years ago, there are a bunch of vulnerabilities found in implementations where the P-curves are the NIST standard curves. They're the US government kind of promulgated curve standards. And they're fine for what they are.
They're fine, yeah.
But they were designed in like the early aughts, I think.
Correct.
Sometime around then, like they're a form of elliptic curve with kind of an older curve equation, where when it was designed, people weren't thinking about directly attacking primitives the way that they do now. So now we have a notion of misuse resistance in the primitives that we work with, right? So we try to adopt primitives where there aren't very many footguns. There aren't a lot of things you have to check for. You just get a lot of security by default. And the P-curve standards aren't that. So when you are...
However, we have better equations now.
We do now.
Those.
But
yeah, like I bet they're all I bet there's a bunch of P56 curves that are being used in JWT implementations that are still using 15-year-old short wire stress curve implementations that are like a ton of if-then exceptions for like if, your curve math isn't working out, which is not easy to maintain.
Like you can kind of visualize in your head like a curve. It doesn't even have to be the right shape. Just imagine a curve in your head and imagine like the XY Cartesian coordinate plane that's plotted on, right? When you're doing the math on the curves, you're dealing in terms of points that are ostensibly on the curve itself, right? So there's a line drawn through this two-dimensional space that is the curve, and you're only meant to be dealing with XY coordinates that are on that curve. But obviously the Cartesian space gives you like the 2D space that you're working in. You can put a point anywhere in space. It doesn't have to be necessarily on a curve, right?
Yep.
And the problem that you have with a bunch of P-curve...
most points aren't on the curve.
Correct, because we're only over a finite field, and there's a whole bunch of points on the regular curve that they're not in the field. Anyway.
Right, and so you have this problem of like a thing you have to check when you're dealing with P-curves is when somebody gives me a curve point because it's baked into a public key or something like that. I'm mangling this, right? But like when I'm given a curve point, I have to check to make sure it's actually on the curve. If it's not, I can't do anything with it. I should just drop the request on the floor. It's totally broken, right? If you don't do that check, you wind up revealing information about your secret key in the response that you generate.
If you compute over that point without checking to see if you should reject it, right?
Yeah.
Yeah.
And so that attack is kind of known as an invalid curve attack. And like the number of things that have to go wrong in a token format to have that problem, it's more than just using the P-curves. And it's more than just encouraging people to use the P-curves. And it's more than not checking to see if you have an invalid curve point. In addition to all that, you also have to be deployed in kind of a static ephemeral mode where there is a single static secret that you can attack, right? So like in the normal case, when you're doing kind of elliptic curve Diffie-Hellman, you're working with ephemeral keys on both sides of it. So there isn't much to learn about the target key that you're necessarily something to learn about the target key that you're attacking, because that key is just local to your session, right? So like you can learn something about it, but it's gone in a second, right? But JWT implementations were deployed in static ephemeral, elliptic curve Diffie-Hellman modes, where there is a long-term target secret. You could submit multiple requests and learn a durable secret that you could then target, right? Like to have that mode of deployment, to make it possible to deploy that way, it's like you put a kick me sign on the whole protocol. So this is an extended rant on a point that
it's like,
that Jonathan made.
Come try all your attacks against my static elliptic curve secret.
It is kind of like the Thunderdome of cryptographic vulnerabilities. I should enjoy it a lot more than I do, but
I mean, going back to original question, Thomas, if I got a spec for that with a none algorithm, I wish that I could just say, like, no, just go away. Like, you're doing everything wrong if you have a none algorithm in the initial design of your system. There is no scenario where that will help anything.
It'll help testing for the broken thing. It'll help me test the broken thing, which is easy for me as a developer and hard for any security engineer.
I don't know. Having implemented TLS before, I think the null cipher supporting that actually makes things harder to test.
Oh, Jesus Christ, I forget.
Wait,
that's
how
still a
does the
thing.
null cipher make TLS harder to test?
Because you need to like build in that code path versus always pushing through some sort of like symmetric crypto. It's not as bad if you already have some amount of agility in it and you're just using it to test, but like the existence of the null one implies that like maybe my nonces aren't fixed length in every message. Maybe I can't hard code that parameter anymore. Maybe I can't hard code this other thing anymore. And so depending on how much agility you've put in already, you might already be in that spot, at which point, like, okay, maybe none does let you debug something, but likely it makes you take a bunch of things that would have previously been hard-coded constants and are now lookups.
Yeah.
So we were going to talk about alternatives to JWT.
Yeah.
But I hadn't had enough time to pummel JWT. So
well,
No.
I just want to add in like the positives on it though again are that you have two services in two different languages that need to verify these things, and you don't want to roll your own signature format. Like you're kind of in a JWT world, and you're probably better off using those with a static profile than you are trying to come up with a different format.
Yeah.
Especially if you don't have someone who does cryptography engineering on your team. And like, if you are doing OIDC, like that's what you've got. And, you know, you have to deal with what you have to deal with. In a lot of cases, you can treat the JWTs as just opaque tokens on your end, which again, then like, who really cares if it's a JWT? If you're getting handed a JWT, but you're just storing it as a binary blob, who cares?
So like, if the only thing that you're trying to solve is an interoperable format for a bunch of different platforms, right? You have some alternatives, some of which have a lot of the same ergonomics as JWT. I think like the best known there is probably PASETO. You guys might know PASETO better than I do.
Yep. Oh, it's been a minute. I think
Is
we're
it
on
PASETO? PASETO?
I always said
Phase two?
PASETO. Yeah.
I watched an Okta screencast about PASETO before we started recording this, and they said PASETO. So from now on, it is PASETO. By the way, I don't know why it's not just PAST, right? If you look at how the acronym actually expands, it's like Platform Agnostic Security Token. Okay, it's PAST, but whenever it's PASETO.
It basically is trying to shave off some of these sharp edges from JWT and just kind of give you very specific parameter sets. And like you either pick like the symmetric one or the asymmetric one, and there's no none, you get no choices. Like you have to version, you do use a different version of PASETO, version 1, version 2, version 3. I think we're up to 3 now. And that's how you get the quote unquote algorithmic flexibility, the cryptographic flexibility. And that kind of goes along with patterns we've learned from things like TLS and WireGuard and other places where you should have one joint and keep it well greased. And that should be versionable. You shouldn't have a smorgasbord of cryptographic algorithms and choices and parameter sets to choose from all in one go. If you want to change them, you have to change the version of the thing that you're using, which only gives you a couple of options.
I'll read the room here. How do we generally feel about PASETO?
I have liked it. Like when I was trying to build stuff and people were like, well, JWT, I'm like, what about PASETO? If you want to use JWT, PASETO basically gives you everything that you want without all the crap that you don't want, except for the fact that it's not baked into, you know, OpenID Connect or all those other things. And there are fewer libraries, but there's still quite a few libraries in different languages.
Before I state my opinion, I want to make sure that my understanding of how they work is actually correct. How very responsible of me. But so there's two main types of PASETOs, right? There's the local and the public.
Mm-hmm.
Deirdre, what's the difference between those?
Oh God, I'm pulling it up again.
You know, like local is some kind of symmetric encryption. I want to say AES GCM.
Yeah, there's public and local shared key encryption, symmetric key, authenticated encryption with associated data, and only lets you use authenticated modes. As with JWT, you get to specify algorithm. There's only those 2 options per version. Yeah. Does that
It
help?
looks like it's a Cha-Cha Poly 1305, which is an AEAD with a nonce, where the nonce is a random byte string then fed to Blake is the nonce. And then I assume that like they must have specified like the ordering of those bytes to be like, here is the nonce, here is the encrypted payload, and here's where the auth tag is within the payload itself.
There's like a V1 of PASETO that I thought was like normie crypto. It might be GCM, and it might be HMAC, and I think it's RSA for the public version. And then there's the V2, which is like the cool kids crypto, which is, you know, Chopoly and, you know, and Blake and all that stuff, and a good curve for the signature format and all that. I don't know the history of it, but to me, they kind of, all this stuff appeared at the same time. So there was like V1 and V2, where V1 exists for people that can't use Cool Kid Crypto.
Yeah.
And then there's local and public for, again, this kind of idea that we need a token standard for both of these things. And they're basically interchangeable with each other.
Yeah, you're correct. V1 is 2048-bit RSA, and authenticated encryption uses AES counter mode with HMAC SHA-384 for the tag.
Well, the nice thing about using like the AEADs for the local symmetric mode is that you don't really have to worry as much about the like type confusion, because you just feed the header that you got in as associated data, which I believe is what they do. And then, you know, if there's a mismatch, it just doesn't work. If you for some reason have local and symmetric tokens, or local and public, in the same app, maybe you're going to have trouble, but you probably shouldn't be doing that anyway, as we discussed earlier. So I do like that. But like, again, the thing that confuses me about PASETO is just that the core issue with JWT was you have to like read off this header first and then figure out what to do. And now PASETO, you still have to read off this header and figure out what to do. There's just only 2 or 3 options for what to do. But like, that doesn't get rid of the main problem. It's just there's 1 or 2 static profiles now that you get to pick from, but it's not a fix to the format.
Right. But that does seem to be like the way that you deploy JWT securely in practice is like basically what PASETO does. Is like you lock down everything that you can lock down, except for the fact that you still have to read in this header, and the way you are doing things is in band, not out of band.
Well, yeah, but then I still have to lock down the header with PASETO,
Yes.
right? Like, hopefully things go wrong less with it. I'd have to like dig into the details of which keys are used where and so on. But like, you still have to make that decision ahead of time.
There's a thread on CFRG. CFRG is the cryptographic research group for the IETF, or for the IRTF, or whatever they call it, right? But it's all the cryptographers that are involved in standards, right? And I think back in 2018, the PASETO authors submitted PASETO to CFRG, which, first of all, kids never do this.
Yeah.
There's no conceivable upside to submitting a new standard to CFRG for any reason ever.
Also, just let someone else do it.
Yes.
Back in 2015, I published this paper with some of my grad student co-authors, Security Rumorich, among other people, about email security and how Stark TLS is being intercepted. And then Zakir presented this at an IETF meeting, and then 4 years later, someone else wrote a new standard. And that's the ideal way to do it. We just showed up, measured a problem, said it was there, talked about it once, then let other people do it. So even if you do want something to be standardized, let the people that get paid to do IETF work for their job, which is a real role. And many of these people have titles like principal engineer at big tech companies. Let them do it.
Like, I paid virtually no attention to CFRG at all until Trevor Perrin posted on his Modern Crypto list that I think Curve 25519, it's either Curve 25519 or Ed 25519, was submitted to CFRG or was being discussed on CFRG, and they were changing Curve 25519. They managed to find an incompatibility to introduce into Curve 25519, right? Which is like, it's literally the only possible outcome.
I might have helped on that RFC.
I don't see a thing that can happen besides that, right? Like, either it's going to do nothing, either like they're going to, oh, this is great, proceed, in which case you learn nothing, or they're going to change something.
As someone who's trying to help with an RFC draft right now, and I've been supposed to look at the latest edits for a week now, and I'm sorry, we kind of have to do it ourselves because there are other drafts for this application of cryptography, and if we don't do the thing for our thing, these other things will get there first and get standardized first and adopted first, and we think they're worse.
I love this all so much. Like, I brought
it's also like a quasi like neutral way for big tech companies to negotiate with each other about how they want to do interop when they already need to do interop without looking like they're a monopoly.
Yes. Or a cartel.
That's the IETF in general, right? That's still not CFRG.
Oh, yes. That's the IETF in general.
CFRG is only the downsides and none of the upsides. But like the PASETO author submitted PASETO to CFRG, and like there was a pretty decent thread there that was critically looking at PASETO, and like there were two big complaints, and one of them is the one that you already brought up, which is just the idea that you're reading a header and then deciding how to cryptographically handle something. And I think for the V1 tokens, they had it back all the way to the type confusion bug between RSA and HMAC, which is crazy to me that you could come up with a new standard that has it. Doesn't, as far as I know, in V2 at least. And there's a note about it now for checking in V1, but of course JWT can add that note too. And then the other critique was just that PASETO is basically a reduced mode of JWT. You could also just specify, a profile of JWT that only does what PASETO does.
But also better cryptographic options as well.
Aren't those basically the same critiques?
Are they?
You're reading a header and then deciding what to do, but we've shrunk it down to two things. Just statically define what profiles you're using. And those are just two sides of the same coin of like, we should just statically define what profiles you're using, define reduced JWT, define reduced PASETO.
I'm pretty sure you're better off with PASETO than you are with JWT, right? Like if you're going to use something, my critique is against the whole idea of JSON tokens to begin with. And if you need a JSON token, fine, PASETO's better than JWT. There's no question about that to me.
Speaking of which, there's all these other things as well. What about is it macarons? Macaroons?
Let's say it's Macaroons.
Macaroons.
I think it's Macaroons.
Macaroons.
Jonathan, introduce us to Macaroons.
Okay, so Macaroons they're an authentication token format that has a couple interesting properties that none of the tokens we've discussed so far have. First, there's only one cryptographic algorithm that is used, which is HMAC.
Cool.
And two, they are extensible in that you can add additional constraints to a token after you've received it.
Neat.
And so if you issue a token and then pass it to a client, the client could then add additional constraints to the token before then using it or passing it to another service.
It's wild. And this is developed by Google. Did they actually deploy it?
It's a paper that was released by Google Research.
Okay.
And then just to clarify, what's the benefit of being able to, like, as a client, reduce the scope of your token and give it to someone else?
I think there are a bunch of benefits. The top ones are, one, you can bind the token to the request in a clean fashion. So you could, for example, include a hash of the request. You could include details about the connection you're sending it over. For example, you could pin the TLS connection. You could just constrain it to a specific API endpoint and then pass it to another service. Or if you're worried about interception, like man in the middle, that kind of thing, you could constrain it in such a way that there's less damage would be done if it was intercepted.
Another cool thing Macaroons do is there's a notion of tokens that are linked to other tokens. The claims in the Macaroon are called caveats, and they have a specific name because they're like, it's really kind of elegantly baked into the construction of the token, how claims get added and how they're all authenticated. It's conceptually, it's really simple, right? It's just a chain of HMAC. So like the previous HMAC output is the key for the next caveat. And you can just kind of roll it forward that way and add as many caveats as you want, which sounds crazy when you think about it. Like you're giving a user a token with the ability to add arbitrary new caveats to it. Like they can,
but it's always bound to the original thing, right?
It is. And also like there's There's a semantic idea in Macaroons that the set of caveats that you have there, those predicates that you're giving, all of them have to be true. So by adding new caveats to a token, you can only be reducing the power that a token has. But another thing you could do, like most of Macaroons just use HBAC, but there's also, they use AEAD crypto to link tokens together. So you would embed a key for a token and a reference to a token. And like the way that usually gets used, like the classic case for that is I can have a token that says I'm allowed to read and write this file name. And I'm allowed to do that as long as this token is accompanied by another token that verifies that I'm user Bob. So that's this idea of a third-party caveat. And what that lets you do is it lets you have like id.myservice.com that issues those tokens, those discharge tokens that say I'm user Bob. That's all those tokens say, right? It's like you're user Bob. And now you can kind of construct tokens that kind of assert both here's the things you're allowed to do, and here's the condition in which you're allowed to do them. I have a lot to say about Macaroons, unlike everything else where I have nothing to say about anything. In part because I'm a developer at a platform company, like we're a small number of engineers competing with all of AWS is a good way to think about my company. And we're doing kind of a Macaroon implementation for our authentication system. It's super valuable for us to be able to take, you have applications running in our cloud, and then you want to like have stats from them. Like you want to hook them up to Grafana, right? The thing you don't want to do is as a user, you don't want to give Grafana an all-purpose authentication token that does anything. You just want to give it access to stats, to Prometheus or whatever, right? Macaroons express that really beautifully. You can take your original God mode token and then turn it into a token that is only useful to Grafana. That's super powerful and interesting, right? So I'm biased. It's another drum that I've beaten is that Macaroons are not used that often, but they're not used often at all. We don't really know anywhere where they're like really commonly used. And this came up recently on a Slack where I was talking to Jonathan about this. And Jonathan, you have some takes on the ecosystem of Macaroons as they exist in public libraries.
Are they spicy takes?
I mean, I would say that the reason why Macaroons aren't used widely is because none of the like public open source implementations of them are any good.
Oh.
I think that the reason for that is Macaroons started as a paper. There is no specification per se. There's just some ideas in a paper that, as far as I know, like never fully implemented anywhere. And so some people came along and said, oh, this is a really cool idea. We should implement that. And they ended up with a system where the caveats are just a opaque blob. And the way that it usually gets implemented is the caveats are this like text-based DSL that you have to parse and it's embedded in the token, and it's just not really good at all. Ooh. And I think that it really hinders adoption in a way that, in the same way that JWT is used everywhere because it kind of works the same way and you get the exact same vulnerabilities everywhere. This like is almost like you get some ingredients and there's not a good enough recipe in order to implement it well. And it is a lot of work for the developers to use the few existing open source libraries that implement it.
Yeah, you say text-based DSL and I get security parser Wibblies from that.
Yeah, I think that you have to implement your own caveat system on top of any Macaroon implementation.
Got it.
And using like just ASCII text for that is not the way to go. I would much prefer a constrained format that is well-defined.
David?
I mean, it's more than like JWTs are used for like identity and maybe like a group membership on the regular case, whereas Macaroon is really more about authorization rather than authentication. It's about delegating capabilities to someone else, kind of like doing OAuth without having to do OAuth all the time, right? It's back on the action side. So if you're just trying to like say, hey, my name is David and I have an account on this web service and I'm in the admin group, there's just no reason at all to be using Macaroons because you don't have any caveats. You just have a very complicated token.
Yeah, I think that's fair. I think, Jonathan, I think you've implemented Macaroons before, at least to play with.
Yeah, I did. Absolutely.
Yeah. And I'm in the thick of it right now. So I ended up like, I guess I'm going to credit this to you. I don't know if I would have done this if I hadn't talked to you about this beforehand, but we did our own complete soup to nuts Macaroon implementation. Like, as I'm sure you discovered, right? When you sit down to write Macaroons, the actual Macaroon construction is just completely trivial to implement, right? It's a very, very simple, thing to, and like, the public Macaroon libraries have a sort of specification to them. Like they use some of the same encoding as protobufs, but not protobufs. And like there's an interoperable format. By the way, I don't understand at all the reason to do interoperable macaroons in that nobody uses macaroons. So there's no one to interoperate with. So kind of adhering to a specification didn't make much sense. But we ended up using message pack. We have like a strongly typed Rust system of caveats, and then we have libraries that call into Rust for it, which makes me feel kind of okay about it. And again, like we're kind of a textbook case. Like it's a Google paper for Google infrastructure and inter-service authentication, which is kind of, we're not Google, but like, we're a small facsimile of Google. So I think it does kind of make sense for us. And I don't know if I would beat the drum as strongly for macaroons having implemented this. I think like a weird thing you run into when you do this is that getting your head wrapped around the macaroon model of what a set of caveats means versus what a bearer token means. Like with a bearer token, I extract the user from the token, then I go to my database and I say, what is this user allowed to do through all of my database associations and things like that. And that is not the macaroon model. The macaroon model is, here's a token. The only way this could have been issued is if the system said it was okay to issue this token cryptographically in the first place. Just trust the token. Just do what the token says you can do. It's not exactly that, but like when you think about what the caveats are, you have to be careful, not just in terms of parsing the caveats themselves, which does scare the crap out of me and is why we have strongly typed caveats, but also just like semantically what a caveat is. Like a caveat has to be a restriction on things that you're able to do with kind of a broader Godmo token, and not like, here's a caveat that says I'm also allowed to do X, Y, and Z things, right? At which point you're kind of screwed, right? Like you're allowing users to add things to tokens that could potentially change, what you're allowed to do with the system.
Yeah. So I think the canonical example would be like, how do I pass a user ID around with macaroons? And the answer is, well, you put it in the body of your message and you add a caveat that constrains that field in your message to that user ID.
I think the thing we're going to end up doing is all of our tokens have a third-party caveat to an authentication service that issues discharge authentication tokens. And then we'll take a user ID from that one signed discharge token. You can't extend a discharge token in the macaroon spec. Like once you get a discharge token, there's an additional hash at the end of it that seals it off, so you can't change it or anything like that. And so like we'll basically treat the discharge authentication token as a bearer token, and I can pull metadata out of that, I guess.
Yeah, when I implemented it, I did explore that, and I was much more comfortable just in that token adding constraints on the message and then expecting the client to just pass in the pieces of metadata that you're expecting to get out as part of the message body that the token is going with.
Yep.
With all of these like authorization systems though, like there's more to it than just the crypto and then like validating the token. Like you still, no matter what you do, have to write some authorization code that says, given all of the stuff that I hopefully just verified, can the user with this role do this action on this object?
Yep.
Assuming you're doing RBAC, right? Someone has to write that and you have to implement that. There can be bugs in that regardless of if there's macaroons or not. You may have to parse the caveats in macaroons, but that's just part of writing the authorization code.
I mean, if you've implemented macaroons correctly, that can I do this is encoded as caveats in the macaroon. So you're not doing any permissions check as part of your authorization cycle. You have a macaroon verifier that gets a bag of data about the request, probably including the actual request body and then some metadata. And then you're running through each of the caveats in the bag of macaroons you got, because there may be third-party macaroons that are discharging caveats. And you just run through and you check all of those. And if you come out with every caveat passed, then the authorization of the request is complete.
Yeah, but you still have to like define, the service still has to know what it's doing, right? And then past that, you still have to be getting a user ID and an action thing somewhere, even if it's in the macaroon, and then comparing that to what you expect. Like you still have to make that call and gather the information about the world that is like, this is the thing
sort of
the service is trying to do, right?
Sort of. So like in our system, right, like when I verify a request with a macaroon, I have the request, I have the organization that the request refers to, I have the application that's running that the request refers to, I have the subservice, like are you dealing with metrics or are you dealing with deployment? I have read or write. Those are attributes of the request itself. And then I have the macaroon, there's like a filter on that. And basically all I'm doing is checking to see, like, does the macaroon say this is allowed, right? And the thing you're trusting is that you couldn't get a macaroon that would allow you to, access somebody else's application or whatever, unless you already had access to that application, right? A really neat thing that you can do with macaroons, and I think also with biscuits, which we should talk about in a second, right, is like the notion of confinement for requests. To make that concrete, like, this is the idea that, like, I'll trust a macaroon if it's accompanied by some other context that says this is okay, right? And in the macaroon paper, their example for that is, I'll trust this request if it comes from a specific IP address, which when I'm reading the paper is like kind of silly, right? Like, when am I ever going to use that? Like, I'm not going to trust IP addresses to begin with. But in our system, we can trust the IPv6 addresses that we have because they encode a bunch of information. We have a software defined network that, verifies that, you can't spoof addresses and things like that. So I can build macaroons that say, if you're a running instance on our network, you could talk to the API and do these things just by dint of being from that address. I can issue a macaroon with a caveat that says, allow this action if you're coming from this specific v6 address. And that actually expresses something useful in our system. But you could do other things like, I'll trust this macaroon if it's, on an MTLS connection with this certificate, or anything else you can think to contextualize a request. You can kind of bake that in.
So not to cut you off, but we talked about Protobuf tokens. We talked about protobufs. There are Protobuf tokens. What are Protobuf tokens and how are they different?
Okay, so this is what I actually ended up implementing when I was implementing an OAuth 2 system for Flynn. And it was the simplest thing that would work for me, which was a signed protobuf message. So you define the exact characteristics of the token that you need. Perhaps you need it to expire and it needs to have a user ID, a group ID, that kind of stuff. And you put that in a protobuf message. And then you have an outer wrapper for that protobuf message that just has two fields that are both bytes fields. There's the actual inner message, which is just encoded as bytes. And then there's a signature field. And you could optionally include a key ID in there if you want the ability to rotate keys easily. And everything else is just in the verifier. So the verifier knows when it either has only one key or it has a key ID, and that has the exact parameters that you're expecting as far as the algorithm. You could just use ED 25519 or similar.
Nice.
And this is the kind of just roll your own token, but in the simplest possible way. And it ends up being like a few hundred lines of code for both making tokens and verifying tokens.
And also, like, all of the things that we say should be out of band and not about parsing a header are that way, right?
Right. You just have to parse this outer message to get the opaque blobs that are the signature and the inner message, and then potentially the key ID.
Yeah.
I think that's the main insight, is that your outer protobuf has a bytes field that is another protobuf, but you don't decode that until after you've checked the signature.
Yeah, exactly.
Good. This is a little bit of the authenticated encryption with associated data. It will not verify if the thing that goes around the whole thing does not verify as well.
Yep.
Who's using this? Is anyone using this?
I have seen and heard rumors that this is used pretty widely in large services. I think that the answer is, like, this is used in places. It's just, it doesn't really have a name outside of the internal names for it. And it's just something that you reach for when you just want something simple and you have the resources to implement it properly in all of the languages that you need within your system.
And also if you are already friendly with protobufs.
Right.
Yeah.
Getting protobuf into your build system is not nice. And like
Yeah.
pre-generating the protobuf implementations and committing them somewhere is also a pain, because those inevitably get out of sync. And
Yep.
I mean, I think it just comes down to, are you already using protobufs or not? You can do this with any other system. I was using protobufs already, so it made sense to do it this way. You could do message pack or any, even some bastardized JSON would work for this. I think that the key insight with this system is that you're just picking the exact properties you need. You just use one algorithm, you bind it to the key, and you don't implement complex stuff that you don't need, and you don't use off-the-shelf libraries that are known to be vulnerable, basically. Or not known to be vulnerable, but that have in the past had vulnerabilities.
Right.
And I think the wrapping, the outer and the inner, is also like a key component of it, because that's what lets you use protobuf, even though the encoding is not like well defined. Like there's multiple encodings for any given message.
Yeah.
Right. There's no single canonical protobuf encoding, correct?
Awesome. And then one more mention, which is, what are biscuits? We've got cookies, tokens, macarons, and now biscuits.
Biscuits are basically what you get when you say, hey, I like macaroons, but I want them to be publicly verifiable, and I would like to use data log for the caveats.
What's data log?
Data log is a specific version of Prolog that allows you to reason about data.
I'm sorry, like there's a lot that makes sense about biscuits, right? And like the prime mover behind biscuits is a really sharp person, whatever. But like I hear like, the variant of Prolog in my tokens, right? Like make that make sense.
You left, but the whole point of like a caveats is to get out a yes no based on like a series of facts, which is the entire purpose of Prolog / data log, right? It's the language that has the intelligence of a 2-year-old because all it does is say yes or no to every question, which is exactly what you want.
Yeah. I think we vaguely have plans to go in depth on biscuits because we all want to learn more about biscuits. So we won't do that right now.
But Jonathan, you should take a second, sell us on biscuits.
I think that they make sense in the same scenarios where macaroons make sense, in that you have a complex system. And unlike macaroons, you don't want to have either a central service that holds the secrets or to propagate token secrets out.
Yeah.
And you want to have your authorization logic in your tokens. So it allows you to have as close to a stateless system for verifying authorization as possible, because the vast majority of your logic is in your tokens. And then there's just enough in the verifier to check the tokens, basically. And it is by far the most flexible option we've discussed if you have more of a kind of sprawling system where you have multiple services that need to act independently of each other.
I guess also, like, in fairness, like I said before, when you actually try to implement like a bunch of policy with macaroon caveats, you wind up in kind of, it gets subtle. And one thing Prolog gives you is some clarity about how you're going to resolve those things, right? Like it's well specified how you're going to actually come up with a yes, no answer, or at least better specified than with kind of arbitrary caveats.
Yeah, I would say that you're basically putting the complexity up front. So by far the most dangerous, one of the most dangerous part of the biscuits is the verifier that is handling the data log. Because if you have a bug in that, you can end up with just wide open where a token may verify when it shouldn't. Whereas I think that with the simpler implementations of macaroons, and certainly the tokens that don't really have policy in them, that's not a potential issue. As soon as you get complicated macaroons, I think that you end up with something similar in complexity.
Yeah.
But using data log actually has some nice properties in that a fully mature system that uses this could actually tell you why a token isn't verifying to a very precise degree that I don't think any other system can.
Sure. They're attenuable too, right? You can take a biscuit and then make a more restrictive biscuit, but biscuits are entirely asymmetric cryptography.
Yeah, that's correct. They have that same property that macaroons has, where you can add additional constraints to them on the client side.
That's like cryptographically tricky to do, isn't it?
Yes. I mean, I think that there is a way to do it with classical asymmetric cryptography. And you can look at the Biscuit repo to see the options. The main problem with it is it uses a lot of bytes and it's kind of slow.
All right. So to kind of cap things off, I think it would be interesting to kind of zoom through a couple of different scenarios where you're doing authentication and talk about what are good options for your tokens, or at least realistic options for your tokens. So starting with the simplest one, you have like one web server that's doing your content and doing your auth and is implemented in some web framework, such as Rails. What do you do there?
I would do a 32-byte random number that's a key into a database.
Yep.
Yeah.
Yep. Your
options are the random key into a database. What about like the things that are just built into the web framework? The one on Rails, the message, I don't remember what it's called, the Fernet in Python. Those are likely reasonable as well until you need to build in revocation, at which point you have some more rows in your database again.
Mm-hmm.
Yep. Moving on to that, let's say you just have two different apps and you want to share login between them, but you control everything. What do we do there?
My answer will be different than your answer, but my answer would be I would share a key, like a symmetric key between those applications, and then do a simple signed, I'd probably just use Rails message encryptor, or Fernet is probably what I would use, the Python Fernet library.
Well, let's say that they're in like different languages.
I would implement Fernet's construction in a different language.
Yeah, I would either do that or implement just the signed protobuf construction that I described.
I would probably go with a static profile JWT set on the root domain, assuming they're sharing a domain.
I think the answer for this is conditional based on whether you have, like, implementing a static profile JWT. Like, in theory, you can do that if you just understand a little bit about security. Implementing a fully custom token, like I suggested, only works if you actually have the resources to safely implement a library that is generating, verifying those tokens, and you're confident in that ability.
Right.
If you were doing single sign-on and you had to choose between SAML and OIDC with JWT and you didn't get to do static profile JWT, which would you pick?
Dear God.
That's just wrong. Don't make that choice.
Like what you do after the SAML. Like, that's kind of a poor question because the SAML, doing SAML is completely unrelated to the token. Like, you can do whatever you want after you do SAML, correct? You're getting an assertion from someone in the form of XML, but you're not using that assertion in your token.
I don't know that I totally agree with how you've boiled that down, right? I think that to me they're doing similar things like OIDC and SAML. They're just using different formats to accomplish it.
Well, I'd still be doing OIDC before SAML.
Okay.
Yeah, I mean, I just implemented OIDC, and you can implement a nice, clean, extremely static profile for the OIDC RP. And then on the IDP side, I would just not use OIDC.
I guess like two things I've learned from this discussion that I didn't know going into it. First of all, the signed protobuf tokens, which are neat.
Yeah.
You know, that sounds like a much cleaner answer to like, what do we do about JWT than trying to come up with a better JavaScript token or a JSON token. That, and also the really simple static, just trust the TLS connection deployment mode for OIDC, which is not a thing I've thought about a lot.
Yes, trust the TLS deployment with an opaque token, I think, is a great way to do OIDC type auth. In fact, I do that at work at the moment. I think if you don't want to trust TLS as much, I wouldn't be doing the discovery because that's actually still trusting TLS. I would just be pinning the keys that I expect or doing some other form of chained, signed JWT public keys.
Although Ryan Sleevey has basically said, please stop doing public key pinning. It's bad. Or
yeah,
cert
but Ryan
pinning.
Sleevey also said that discovery for OIDC means that you can, if you can get a TLS certificate misissued for like a minute through BGP and you impersonate the discovery endpoint, now I've just taken over your IDP, right? Like, so you can get the same properties of SAML in the sense that you have to put the certificates in beforehand by simply just putting in the JWT keys, public keys that you expect in OIDC, and doing the verification, but without doing the discovery.
This is a Twitter discussion that drove Ryan Sleevey so far around the bend that he possibly recommended using DNSSEC and Dane to solve this problem.
Oh, who wins? No one wins if you reduce to DNSSEC.
Well, I think no one wins with auth tokens in general because the answer is basically as soon as you get past one server, everything sucks.
Okay, does that bring us down to sign in with a third party? If we design it from scratch, what would we do?
If you get to design it yourself from scratch, you'd use signed protobuf tokens, right? You do something like that. The problem is you never get to, like, when these discussions come up, people start talking about like, what do I use instead of JWT with OIDC? And it's like, that's not a real discussion, right? OIDC is JWT.
Yeah, like you have to integrate with something somewhere. And if you aren't, you will.
I'd be doing constrained OIDC where from the client's perspective, I'm just getting an opaque token back that only works for this one thing.
Okay.
And on the IDP side, you need to be able to discern between what you've issued to who, but then it's really just a problem on the IDP. And, making that the IDP's problem means that this is now just a Google problem and a Facebook problem or an Auth0 problem and not like everybody else's problem.
Awesome. So, I think the answer for this whole thing is signed protobuf tokens. Just use them everywhere you possibly can. And Jonathan, thank you so much for introducing them to me. This has been awesome.
Yeah, thanks for having me. This has been fun.
Does it have to be protobuf? Can it be something? It can be something else.
It can be anything.
Right?
I mean, I think that the canonical implementation that I've seen of this is protobuf, but there's no reason you couldn't use like message pack or whatever your favorite static serialization.
I could have a struct in Rust and I could SERDI it into my favorite encoding And
That's how we did Macaroons with Message Pack. Just certain.
bam.
Yep.
All right, I'm just gonna do this forever. Did you open source your thing, Thomas?
We'll never open source our thing.
Fuck.
Well, I think in the future we should have Jonathan back to talk more in depth about Biscuits and
Yes.
Thomas to talk more in depth about how the hell he has authenticated source IP addresses.
Yes.
Thanks to WireGuard.
Honestly, you should probably have the author of Biscuits on.
We've talked to them as well, so we might try and get like a nice panel of let's talk about Biscuits. But yes, thank you so much for coming. Any final closing thoughts?
I'm spent. I'm
Cool.
done.
All right. Thank you. Cool.
Thanks, everyone.